Hello everybody, I'm Nick, and this time I'm going to show you how you can get started with BDD or behavior driven development in .NET. And I'm going to be using something called SpecFlow to achieve that. There are multiple libraries for you to be able to implement or actually practice BDD in .NET, but SpecFlow is the most mature and it actually has the biggest ecosystem around everything else, so I'm going to be using that. There are many others, and by no means am I saying that SpecFlow is the best, but it does the fundamentals right, so that's why I'm going to be showing you the concept using that library. What I want to say is that I'm not going to be diving into the concept itself in this video. This is more about how you can actually get your hands dirty and write using BDD, write code. There are plenty of videos explaining the concept, and for you to be landing here, I'm assuming that you've watched one. You want to see how you can actually implement it in C# and .NET. That being said, I'm going to briefly explain what BDD is now, but if you just care about the code, just skip to the timestamp in the timeline of the video and go straight into the implementation. Now, behavior-driven development, or BDD, sounds a lot like test-driven development, or TDD, which we've talked in this channel before. And the idea that carries over is that you don't start from your code, your implementation, you start from an external point which is trying to test or drive the implementation. In TDD, it's your unit test, and you say what the unit should be doing. In BDD, it is the acceptance criteria, or the feature, or the scenario. Those different meanings, and I'm going to explain where they are as I'm writing them. The advantage of BDD is that anybody can write at least the specification of a test in BDD, and anybody can read it. I can give it to my business analyst, product owner. In fact, ideally, you want your product people and your business people to actually write the specs, and you just do the mapping and you implement the code behind that spec. This will make way more sense as I am actually showing you how to do this in practice. But fundamentally, it's the idea that the behavior of your system drives the code and the implementation of the system. You can think of it as an evolution from TDD, or like a very nice marriage between TDD and ATDD, which is acceptance test driven development. Those are concepts that are just lending ideas from one another to achieve this one. And if you see this from a DDD perspective, domain-driven development perspective, it is actually diving more into the domain itself rather than something like TDD, which is very focused on the unit. Let's just dive straight into the code, because I think you're going to understand the concept, even if you're unfamiliar with it, way easier by watching me actually practice it and talk you through the process. So what I'm going to do first is I'm going to create a test project. I'm not going to use a unit test project here. I'm just going to go ahead and create a simple class library. And I'm going to copy that. And I'm going to say, I could say BDD. I'm going to say tests. Naming is completely up to you. I could just say test.behavioral or behavior. And now I have that. I'm going to go ahead and create it. And I'm going to add a few NuGet packages or libraries in this project. The first thing I want to add is, let's go to the NuGet packages. I want to go ahead and add SpecFlow. So I'm going to type SpecFlow.xUnit. So it's SpecFlow with xUnit as a runner behind the scenes. And I'm going to go ahead and install that. Then I'm going to add Fluent Assertions, which is my favorite package for doing assertions during testing. We will be asserting different values, so I want to have that here. I'm also going to add the Microsoft where is it? .NET.test.sdk. This is the main testing.NET library, and that should be it. So now I have my class library and I have the libraries in. So what I want to do now is I'm going to go ahead and create 3 folders. I'm going to create one called features, another one called hooks, and another one called steps. So in BDD we have something called a feature, and a feature is a feature of your system, very self-explanatory, and those features are satisfied based on scenarios. And scenarios, you can think of them as acceptance criteria. If you've worked in an agile team that is using Jira tickets and you're doing your assertions or your acceptance criteria based on the given when then approach, it's very much the same thing. And that's what we're trying to achieve here, a human readable in plain English feature or test, and we can drive our test through that feature. What I should say is that in my IDE, which is JetBrains Rider, I have actually installed the SpecFlow plugin, which enables support for syntax highlighting, go to reference, auto-create steps and stuff like that. There's a similar extension for Visual Studio if you're using it. I don't know about Visual Studio Code, but I think there is something for that as well. So that's also something else that you basically need to get started. So what I'm going to do is I'm going to create a feature file, and I'm going to talk to you about what we're going to be doing in this video, right? So imagine there is a system where we are selling clothes, and if you're a logged out user, so a guest, and you're buying something, you're paying full price for the items. So if a t-shirt is costing you $100, then you're going to pay that amount. But if you're a logged in user, you get an exclusive discount and you're going to pay 5% less, so $95. So we're going to be implementing that logic into our feature through a couple of scenarios. So let's start with that. And I'm going to say logged in discount dot feature. So we have a dot feature file, and actually Rider has specific highlighting for that, because dot feature is detected as something that is expecting to have a syntax called gherkin, and gherkin is effectively English in a very structured way. I'm going to show you how that looks like. So first you start with a feature. So you say feature and you describe your feature, and you say logged in users have a discount. Simple as that. And then after that you say as a, and the persona as a user, I want to have a 5% discount when I am logged in. So this very much reads like English. Now there's no mapping in that specific phrase, but just by looking at the feature, this should describe what this specific feature file is dedicated to. What are you doing? Okay, I'm checking, I'm making sure, I'm testing for a user that has a 5% discount when they're logged in. So let's go ahead and create a couple of scenarios, right? The ones we want to implement. So scenario, and we give it a name. Guest users, so users that are not logged in, should pay full price. And we're going to describe this scenario in gherkin with given when then, and you can have the end word as well. So it looks like this: given a user that is not logged in when a t-shirt is added to the basket. In fact, a t-shirt that costs 5 GBP is added to the basket, then the basket value is 5 GBP. This looks very much like English, right? You can see it and you can read it. We have red squiggly lines, and that's because we don't have steps implementing those ideas. But fundamentally, that's what your test looks like. That's what you could be given by your product analyst or your business analyst or your product owner, and they could write this. Anybody could write this. Anybody can read this. This is the beauty of it. And we can actually make this a bit more elaborate, right? So what we can say is, given a user that is not logged in and an empty basket, when a t-shirt that costs 5 GB is added to the basket, then the value is 5 GBP. Now this is one of the scenarios. I'm gonna also write the other one, which is, and I'm actually not gonna copy it, I'm just gonna type it. So scenario 2 is logged in users should have a 5% discount. I'm gonna say given a user that is logged in and an empty basket, when a t-shirt or when, I don't know, a dress that costs 100 GBP is added to the basket, then the basket value is, well, it should be 95 GBP, right? Because we want to represent a 5% discount. So now we have our tests and we're ready to generate our steps. What you're seeing here is my automatic test running. Every time I save, I'm running my tests, and you will see that currently there's no tests to run, but when we start implementing that, you're gonna see them there. So now that I have my feature, if I was to build that project, a C# file called loggedindiscount.feature.cs would show up with a whole bunch of generated code. The beauty of SpecFlow is that it will actually generate the C# code to make those tests run using the runner you selected. So what I'm gonna do is I'm gonna leave this as it is, and I'm gonna create under steps a new class, and I'm gonna call this logged in discount steps. I'm not gonna do anything. All I'm gonna do is I'm gonna add a binding attribute at the top of the class, and I need this so my feature file detects the steps in my steps file. So I'm gonna go here, and because I have the plugin, I can do create step, and this will automatically go to the only step file that I have and create the step and generate the code for it. If I had more than one step, then I would be able to choose where I want it to be generated. But now I have my given generated for me, and then I can do the same for the second one. So an empty basket is also generated. Now I have this, and I'll come back to that in a second. And then I have the last one as well. You will see that the squiggly lines here are still here because this is not created, so I'm going to create that as well, but I'm not going to attach these two, because a good thing about this language is that you can actually parameterize it. So let me move that up top, and I'm not going to implement the methods, but I'm going to parameterize the given when thens a little bit to make it more generic. So what I want to do is I want to see, okay, this looks fine, I don't need to touch this looks fine. Here I could actually parameterize this to make it more generic. A t-shirt is just an item name. So what I'm going to do instead is I'm going to say, I can use regex here, and you can see I have autocomplete with rider, and I'm going to match one parameter with regex, which is the item name. So string item name or product name. And then I'm going to also do that for the price. I could do it for the currency as well if you want to check FX rates and stuff like that. And I'm going to say decimal price. And now this is generic, and I'm going to also do the same thing for the thing at the bottom. So it's the 5 GBP. I'm going to say basket value, and now the moment I save, these squiggly lines here should go away, and they do go away indeed, because the given when thens are matching the regex, and I can actually reuse the same steps because the logic is the same. It's the parameters that are different. So things like 5, 5, 95, those are parameters now which I can bake into my logic, and I can reuse the steps. Starts coming together, doesn't it? I think it's a very elegant way and a very readable way to write your behavior. The problem with this concept altogether, or the drawback, is that because there's no mocking involved and you're actually running the thing, targeting potentially a mock database, but with integrated systems, it can take way longer than what a unit test would take. Unit tests usually take seconds. This can actually take minutes to run because you are targeting a real system and you're validating it across the feature, not across a unit. What I'm not going to be talking about this video, but if you want me to, I can actually make a follow-up video to this, is hooks. And hooks give us the ability to create setups and teardowns in our tests. So we can say that before you run this feature or before you run this scenario, spin up a database, or create this, or shut down the database and tear it down. We're not going to be doing it here because I want to keep the video small and the scope small, but realistically you would also be using hooks. I will have links in the documentation of SpecFlow in the description, so you can actually go and check it out yourself if you want, but for now we're going to only be focusing on features and steps. Now what I'm also going to do is I'm going to create a new project, and I'm going to call it I don't know, service, which is the pricing service or whatever service we're going to be pretending that we're using in this system, because I want to add a few things like a pricing service and a basket service, maybe just some logic in there. What I'm gonna do is I'm gonna go ahead and say I'm gonna add a reference to that file, so refer to that project, and that's where we're gonna create our code when we start running our tests. Now if I was to save and trigger a test running, you should be able to see the two features I have. So guest users should pay full price and logged in users should pay a 5% discount. If I run those tests, because I have the pending step, they will fail. And now we're in the red step of the process, where now we need to implement the code to satisfy those conditions. You could actually already have the code to satisfy those conditions in some scenarios, because I mean, it's called behavior-driven development, but it's something you can implement halfway through the project as well. It's not prohibitive like what unit testing would be. So keep that in mind. So I'm gonna hide that for now. And what I'm gonna do is I'm gonna copy a bunch of code that I already have, and I'm gonna talk you through the code. It's the service code which we will be using. So now I'm pretending that I'm writing code that satisfies those conditions. So now I've copied over my code and I have a bunch of classes in the same file. It's not the best practice. You should actually separate them and properly structure this project. For economy of time and economy of this video, I'm actually just gonna have it in the same file, but don't do this. So now that I have the code, I'm gonna start satisfying those conditions to make the tests pass. So let me just expand this so you can see them running and failing. And I'm going to enable continuous testing. So every time I save, so Control S, it's going to rerun the tests. That's what you can see now every time I save. So perfect. I'm going to go ahead and start satisfying those tests. And first what I want is I'm going to have a user. So private user, and that's the user we're going to use for those tests. Side note, for those who are more familiar with SpecFlow, I'm well aware that you can actually inject and share context and do way more complicated things. But this is something we're going to follow up in a next video, not on this one. So I know that some of those things are not the absolute best practice, but for the sake of what I'm showing here and with the runner I'm using, XUnit, it will work fine. So we have the user, which we're gonna create in either of the givens that refer to the user. Then we have the basket, which we're gonna initialize in that step. And then we need products. So I can have actually a list of products based on how many clauses I have and add them in the basket. Actually, I'll see if I need this. Let me comment it out. First, what I need is a user. So what I'm going to say is, given a user that is not logged in, so I'm going to say user equals new user is logged in equals false. And let me just make it a bit clearer. So we have a user that is not logged in, and we also have the given a user that is logged in. And in this scenario, I'm going to say logged in true. Then we also have an empty basket, and the basket is tied to the user. So I'm going to say basket equals new basket. And we have user equals the user we have initialized already. So this is failing because the code wasn't compiling. My tests are still failing because they're validating against the behavior. That's the beauty of it. We're gonna pass. They're gonna pass when we satisfy those conditions with our code. And then what I need is to, let me just put that in a new line so you can see what's going on. And then we need to do the math and say, we need to use a pricing service actually. So I'm gonna create a pricing service here, private read only pricing service equals a new pricing service. And I'm gonna use that below. So what I'm gonna say is when a t-shirt that costs 1 GBP is added to the basket. Actually, I'm not using it here. Here what I want to say is basket.products.add, and I'm going to add this new product, which is name, item name, and price equals price. Here we go. And last but not least, I'm gonna get the basket, that's the expected basket value. So I'm gonna say expected basket value, and then I'm gonna get the actual, so basket value equals underscore pricing service dot get basket total amount, which we're gonna use the basket for. Here you go, and we're gonna set that, so basket value should be, and then we're gonna use the expected. And now if I press save, my test should be passing, and they are passing because my conditions in the feature file are now satisfied. If I was to change that, so let's do an experiment, right? Let's say that the basket value is not 95, the basket value is 50, so 50% discount. If I save and my test run, one of them is failing because this condition, this behavioral condition, is not satisfied. That is what we are achieving with this thing. And the good thing about this is I can give this to my product manager, my product owner, my product whatever, and then I can see exactly what my application is doing. In order for you to successfully implement such a thing in your team, everybody needs to be on the same page, including product, QA engineers. It's absolutely not something which you can just drop in and expect everybody to be on the same page. But I think that with proper training, if you feel the need to have something like that in your team, you can actually get quite a bit out of it. The problem with such tests, however, is that yes, a test can fail, but it can fail for any reason, and usually you don't exactly know why it failed, because in unit tests, you have this very isolated unit that you're testing and you know exactly what happened. The behavioral test can actually be testing external services as well as part of the flow, so mocked or not. So it becomes harder to identify exactly what's going wrong. As a first step, I think that this explains a real world scenario where you can actually use BDD. That being said, we only are scratching the surface, so if you want me to continue the series, please leave a comment in the description down below, and I'm more than happy to make more videos on the subject. That's all I have for you for today. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find a link in the description down below. Leave a like if you liked this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.